terminology you need to know for. So in binary, there's a lot of things you need to know. For example, so basically, you should start off like learning about like stuff that's not really related to binary, but still useful. For example, a string. So a string is a sequence of bits of any size. So for example, ABC, that's a string. Also like 0, 1, 2, that's also a string. So strings are useful in computer programming. And a bit is the tiniest possible piece of information. So it can only have two possible distinct states, like they're usually a 0 or 1. It can be anything from on and off, true or false, and B, or even like some random number and a different random number. So those are bits. And a byte is 8 bits in an ordered sequence. So order matters. And a binary, so binary is what we're learning about today. And so in binary, it's a different method of counting. So instead of using base 2, we use base 10. So instead of, like, for example, in base 10, we count from 0 to 9, for example, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But in binary, we use 0 and 1. Radix point, in the radix point is like the dot in the number that separates the integer and fractional parts. And binary notation, like this is called subscript, and it means that a number isn't binary. So basically, this is a brief intro into binary. So basically, this is base 10. You do 4 times 10 squared plus 2 times 10 to the power of 1. So we did this in our heads. We probably don't like consciously think about it, but this is still how it goes. So yeah. But in binary, instead of multiplying by powers of 10, like this is a power of 10, we multiply it by powers of 2. So this is a 2 here. And we also have decimal points for non-integer numbers. So we just go to negative powers of 2. For example, 1/2, 1/4, and so on. And we also have irrational numbers in binary. For example, we still use like 1/2, 1/4, and so on, except we go on forever. So yeah. And in binary arithmetic, there's just because we're using a different base doesn't mean we can't use math. So we have binary arithmetic. So when adding two numbers in decimal, you have to add each place value. And if the sum of the two numbers is greater than 10, you get the carry. So for example, like 5 plus 6, that's 11, but you don't write 11 in just one spot, you write in two spots. So that's called carrying. So for example, 1 in binary plus 1 in binary is equal to 10 in binary or equal to 2. So yeah. And in subtraction, it's basically the same, and borrowing works the same way as with decimals. So with multiplying two numbers, so what you're supposed to do is stack the numbers, and for each digit in the bottom row, if the number is 0, do nothing. Otherwise, take the top part, like for example, take this top part, and add the power of 2 in the digit in the bottom row, number zeros to the end, and keep that total. So for example, 110, so there's a 0 here, so do nothing. There's another 0 here, you do nothing. And then there's like a 100, right? So 100, you add, there's 2 powers of 2, and there's 2 powers of 2 there. So you add 2 zeros, and the final answer is 11000. And with division, it's basically the same thing. You keep subtracting multiples of 2 until you get until you get 0. So yeah. And other bases, so like any base works. Usually it has to be greater than 2. Like you can also have fractional bases and like bases which are pi, but they're very uncommon, and you'll probably not need to know about them. Yeah. So these are some common bases. So decimal is the one that we use right now, and hexadecimal is also very useful. It's the representation of colors. And decimal to binary conversion. So say you have a number 87, right? So then so basically in binary we have a power of 2 here. So right, so you have 64. So that means a binary number always starts with 1, just like a decimal number never starts with 0. So you have a 1 here. That means that there's 64, right? So you have 64. So that means there's a 64 in here, and then there's a 0 because the next lowest power of 2 is 32, and 32 plus 64 is greater than 87. And basically that you keep doing that until you get to 0. And then if there's a like fraction or like not a whole number, then you have to keep going forever unless it's a terminating decimal. But yeah. And then So when there's a decimal point, you just do the same thing, and then you multiply. So if you want to make it simpler, you can multiply by, you can like shift the decimal place over, but you have to remember to shift the decimal place back there when you're done. So yeah. So in computers, it's always using binary because like it's much easier. Like for example, in computers, you can store data using like on and off because like electric switches, and this is much easier than storing like in base 10 because you need to have 10 states, which is very hard. So memory and storage in computers is stored in binary, like I said earlier. Memory, computers can become amnesia and forget their data. So memory is short term and but can operate at high speeds compared to storage. And stored with transistors and like with on as one and off as zero. So storage is long term as opposed to memory, and stores data even when the device is off. For example, like a USB is long term storage. Both of these are stored in chunks. A chunk can be any power of two, size of power 2, and larger chunks are used when there's like more data to store. For example, you only need a very small chunk to store like a single number. We need a large chunk to store the output of the screen, for example. And then there's many types. So in most computer languages, so for example, 0, 1, 0, 1, 0, 1, 0, 0 might represent the ASCII character T, or it could also represent the number 84. So types are a way of telling between the two. So for example, there's numeric types, which like an integer is a numeric type because it's like a number, and but then there's also strings. Like for example, T is a string because it's a character. And there's also this thing called a file. So like we normally use files without thinking about what they are, but a file is a collection of data using binary. So this is just an explanation about files. So normally files contain headers and a magic number, which like identify the file. And this is all done in binary, so you can imagine how hard it is. And so data compression. So data compression is like normally used with binary. So for example, we have run length encoding. So like in binary, there's only two possible numbers, like 0, 1. So that's why there's a lot of repetition. Like one in like the number 1010, you could store like 1, 1 because if 1 always represents 10, then that would be much easier to store. So that's basically run length encoding. And yeah. Steganography is the practice of concealing a message within another message or physical object. So because binary, there's like no one wants to read through binary, like no one wants to read through all the ones and zeros. That's why computers have to do it. And since computers are notoriously bad at identifying stuff without like machine learning, they're bad at machine learning. This is why you're allowed to hide stuff in steganography due to binary. So floats in computers. So for example, in a float, you can't really store the decimal place or the radix point. So what you're supposed to do is there's standard. So first you have the sign bit. The sign bit is like if it's negative or positive, and then you have exponent. So say you have like 1.1 in binary, then the exponent would be just 1 because but if you have like if you have 11.1, then the exponent would be 2 because it's like 2 place values. So this is how you store floats in computers. And then so logic, so Boolean representation. So Booleans are representation of a bit using true and false. So for example, 1 is greater than 2, that's a false statement. So that's represented by 0. And like 1 less than 2, that's a true statement, and that would be represented by 1. So a logic gate is like takes 1 or 2 inputs and outputs an output, which is like another Boolean. So for example, not of a single number is the opposite. So like 0 goes to 1 and 1 goes to 0. And there's like plenty of logic gates because there's plenty of use cases. So it's also bugs with binary. So for example, say you do 9 plus 1, but you only have 1 digit stored, right? Then there's like you could do like 9 plus 1 equals 9, or you could do like 9 plus 1 equals 0. And both of those, like you can never store 10 if you only have 1 digit, which means that's always an issue. So that's integer overflow. And segmentation fault is when the program tries to access memory it hasn't been given permission to access. And some famous bugs are like the Y2K error, and when in the turn of the millennia, like dates were stored as 2 digits, but then it thought it was 1900 again, and there were bugs. And in 2038, which is in like 17 years, that there's going to be another bug, and that might affect you. So and thank you for watching this workshop.